Hey, geometry students, this video is for the study guide on similar triangles for our upcoming test on similar triangles. So we are starting in topic 2, and we'll come back to topic 1 at the end. We're starting in topic 2 where we have similar figures. Let's see. So we are finding the scale factor of figure A to figure B. So all that means that we need to do is pick a side in figure A and pick the corresponding side in figure B. So 36 is the largest side in figure A, 20 is the largest side in figure B, so we get 36 over 20 as a fraction. We can clear this out. So we're going to do 36 divided by 20 is 1.8, and then we do math, enter. So our scale factor is 9/5. This shape is 1.8 times larger than this one. We could also write 9 to 5. 9 of these is 5 of those. The scale factor in 4, again, just choose a side. I would choose 12 as the smallest and 9 is the smallest. So we're going to have from figure B to figure A. So that means we need to do a number from B first over a number from A. So we would have 9 over 12, which reduces to be 3/4. So our scale factor is 3 to 4. We write our answer as a series of numbers with a colon. So for number 5, we have our similarity statement. KLJ is similar to VWU. Remember, the similarity statement tells you the sides that correspond to each other. So we know KJ corresponds to UV. So that's going to be 4x minus 23 over 4x minus 23 over 2x plus 2. And that equals, it would have to be 25 over 20. Then we cross multiply. So we have 20 times 4x minus 23. That's going to be ATX minus 460 equals 50x plus 50. We could subtract 50x from both sides. So we get 30x minus 460 equals 50. We could then add 460 to both sides, so we get 30x equals 510. And finally, if we have 30x equals 510, we could divide both sides by 30, and x would equal 17. For number 6, we have triangle NML is similar to triangle SRL. Again, the similarity statement tells you the sides that correspond to each other. So we know NL corresponds to SL, so that's one ratio. So we have 3x minus 1 over x plus 7. And then ML corresponds to RL, so we're going to have 28 over 24. Now, if you want, you could reduce this fraction, or not reduce, simplify the fraction. 4 divides into both, so that's going to be 7 over 6 instead. So now if we cross multiply, we get smaller numbers if we want to do mental math. So we get 18x minus 6, 6 times 3x minus 1, equals 7 times x plus 7 is going to be 7x plus 49. And then we subtract 7x from both sides. We get 11x minus 6 equals 49. We add 6 to both sides. We get 11x equals 55. And we divide both sides by 11. X would equal 5. So for these problems, the similarity statement tells you the ratio that you should make. Now, there are other ways to set these up and get different ratios that are equal, but I would always use the similarity statement so that we're working consistently, so we know we can consistently get the correct answer. For number 7, similar kind of problem, we have DEF is similar to JKL. So we know EF is similar to KL. That's, well, is proportional to AL. So we're going to have x plus 11 divided by 6x plus 3. and that's going to equal ED is proportional to JK according to our similarity statement. So that's going to be 10 over 25. This fraction simplifies to be 2/5. So if we multiply 5 times x plus 11, we get 5x plus 55 equals 12x plus 6. Let's subtract 12x. So we get negative 7x plus 55 equals 6. Subtract 55, we get negative 7x equals negative 49. And so x equals 7. X equals 7. Number 8, similar kind of problem. We have PQR is similar to triangle TSR, and we need to find the length of SR. I'm sorry, let's go back to number 7 for a moment. It said find the length of KL. So x equals 7. That's going to tell us that KL equals 6 times 7 plus 3, which is 45. Excuse me. So now for number 8, we're trying to find SR. So PQR is similar to TSR, so we know PR is proportional to TR. So we would have 60 over 4x minus 26 equals, let's see. So we did PR, then TR. So now we're going to do QR and SR. So that's going to give us 38 over 2x minus 1. If we cross multiply, we get 120x minus 60 equals 4 times 38 is 152. So 152x minus 36 times 28, no clue. 1008. So minus 1008. Make sure that we did this one. 60 over 4x minus 26, 38 over 2x minus 1, cross multiply, sure. So if we subtract 120x from both sides, we get negative 60 equals 32x. If we add 108 to both sides, I believe that's going to be 948. 1008 minus 60 is 948. So we would get 948 equals 32x, and 948 divided by 32, 29 point something is not right. Let's see, 60 over, so PR corresponds to TR, 60 over 4x minus 26, and 38 over 2x minus 1, 60 times, maybe my math on 38 times 4 is 152, that's correct. 38 times 4 is 152, 38 times 26. Oh, I did 36 times 28. I'm sorry, 38 times 26 is 988. So this value should be 988. So when we add, we'll take this step back. So when we add, we subtract 120x up here, we will get negative 60 equals 152x minus 988. And so then when we add 988, we get, let's use a calculator, 988 minus 60 is 928. So 928 equals, man, this is riddled with mistakes. This should be 32x. Excuse me, 32x minus 988 because we subtracted 120. When we add 988, we get 928. I don't know where I crossed it out. 928 equals 32x, and we divide both sides by 32. So 928 divided by 32 is 29. That makes way more sense. 29 equals x. So we're trying to find SR, and SR is going to be 2 times 29 minus 1. So 2 times 29 minus 1 is 58 minus 1 is 57. So my apologies on this. Clearly, we should have 6 over 4x minus 26, 38 over 2x minus 1. When we cross multiply, we get 60 times 2x minus 1 is 120x minus 60. 38 times 4x minus 26 is 152x. My mistake was doing 36 times 28 and not 38 times 26, and that will give us negative 988. For number 9, we have the scale factor is 4 to 3, so 4 over 3. And we're trying to find the perimeter of triangle WXY. There are 2 ways to do this. You could multiply each side divide each side by 4/3 or whatever and get this, or we could just find the perimeter of triangle CDE. That's going to be 13 plus 29 is 42 plus 22, 64. So 64. And then the perimeter of WXY, we don't know, we'll call X. And we're going to say X equals the perimeter of triangle WXY. So if triangles are similar, because each side is proportional to the side of another triangle, the perimeters, which is just the sums of those sides, has to be proportional as well. And that our ratio is always going to equal whatever the scale factor is, which is 4/3. So we have 4/3 equals 64 over x. We can multiply, we get 4x equals 3 times 64 is 192. So x is going to equal, I bet you, 48. 192 divided by 4 is 48. So x equals 48. So that means that the perimeter of WXY is 48. When it comes to topic 3, where we're proving triangles similar, remember the shortcut that not shortcut, but the step we used in class was however many sides are labeled, that tells you which similarity statement to use. So 0 sides means angle similarity, possibly. 1 side is going to mean side angle side similarity. I'm sorry, not 1, 2. 2 sides is going to be side angle side similarity. And 3 sides is going to mean side similarity. And again, not that the answer is definitely that, but that's the similarity theorem that we should check. So in number 10, in one triangle, we have 2 sides. So that means that side angle side is going to be the thing that we check for. So for side angle side to be accurate, we have to have a pair of congruent angles between the 2 sides. So for the side, for PM and MK, that angle M is equal to angle LMQ. So PMK is congruent to LMQ, right? That PMK is congruent to angle LMQ, vertical angles. So now we need to check if the ratios of the corresponding sides are equal. So 15 is the smaller side, 21 is the smaller side. So if 15 over 21 equals, and we don't know that it does, 28 over 39.2, then they are similar by side angle side. And this is what we check on our calculator. So we have 15 divided by 21, that's this decimal, and 28 divided by 39.2 is exactly the same decimal. So these are equal, what's this as a fraction? 5/7. So both fractions equal 5/7. So they are similar by side angle side similarity. So we have triangle PKM is similar to triangle QML. For number 11, notice that we're given 0 sides. So that means that we're only going to check for angle. Now our 2 triangles are triangle ADE and triangle CAB. So if we want to find angle D, we can do 180 minus 47 minus 38. So this angle is 95 degrees. And if we want to find angle B, we can do 180 minus 98 minus 47. That's 35 degrees. So in triangle CDE, we have 47, 95, and 38. In triangle CAB, we have 47, 98, and 35. This should be a 35 in case that's not clear, 35. So because those triangles have different, they only have one congruent angle, and that's the 47. These are similar by they are not similar. Because for angle similarity, we have to have two pairs of congruent angles. For number 12, so we have three sides given. So we're going to test for side similarity. And let's see, we have small, middle, large, small, small, middle, large. So we need to check if 8 over 10 is equal to, let's see, 9 over 11.25. And we need to check if that's equal to 12 over 15. So all you have to do is type each ratio in your calculator. It's 0.8. It's also 0.8. And 12 divided by 15 is going to be 0.8. So all three ratios are 0.8. So the answer is, so these all equal 4/5. The answer is they are similar by side similarity, the only one we needed to test for. So triangle RYN, so medium to large, we need to do ADE. So triangle ADE. For number 13, we have a triangle where we have parallel lines. So this line PS is parallel to this line. We have a pair of vertical angles in the middle. So remember, when we have parallel lines, you can connect the parallel lines and make a Z, and the angles within the Z are congruent to each other. So that means that angle S is congruent to angle C. We could also connect these lines using PF, and angle P would be congruent to angle F, but for angle similarity, and we know it's angle similarity because we don't have any sides labeled, and we have two pairs of congruent angles. So we know angle S is congruent to angle C, and we know angle, well, we have to call this a full angle, so angle PAS is congruent to angle PAS is congruent to angle FAC. So PAS is congruent to similar to triangle FAC. For 34, not 34, for number 14, we have a pair of congruent angles already. Angle M is congruent to angle Q. We know that because it's given. And we have two sides, so the possibility of a similarity statement is only side similarity. To test for this, now we need, we have our small side, we have our large side, we have small, we have large. So we need to check if the ratio of 30 over 44 equals 32 over 48. So that answer probably should be not similar because this reduces to be 2/3. So 30 divided by 44 is 0.68. And 32 divided by 48 is going to be 0.666, repeating. The answer here is not similar because the ratios are not equal. So 30 over 44 is not equal to 32 over 48. So last is, for this section, is 15, where we have a smaller triangle where we have sides 32, and if this side, the whole thing is 45, and this little segment is 9, it means that this segment is 36. So both triangle JNK and triangle RNV, we have angle N is congruent to angle n because it's in both triangles. So that takes care of the angle part of side, angle, side. So now we need to check if the ratios of corresponding sides are equal. So the small side is 32, and in the smaller triangle we have 32. In the larger triangle RNV, Rn is 40. So does 32 over 40 equal 36 over 45? The answer to that should be yes, because both of those reduce to be 4/5. So 32 over 40 and 36 divided by 45 is 0.8. So the answer is both of these equal as a fraction 4/5. So they are similar by side, angle, side. And so that would mean that triangle JKN is similar to triangle RVN. For number 16, where we have parallel lines and proportional parts, when in a triangle you have a segment interior to the triangle is parallel to a base of a triangle, you can separate this into smaller segments. So this entire segment is 28. This little segment from the top of the triangle to here is 7. What always happens is x over 18, and like I say, x divided by 18 equals 7 over 21. You can think about this line being a fraction and these two lines together being an equal sign. So x over 18 equals 7 divided by 21. So that's something to look out for if you need some help doing that. So we end up with 20. So up here we're going to get 21x equals 7 times 18 is 126. Divide both sides by 21. X equals 6. Same thing for number 17. We have a pair of parallel lines. One of the bases is parallel to a segment interior to the triangle. So that's going to be x plus 5 over 15 equals 5x plus 1 over 35. We can cross multiply, so we would get 35x plus 5 times 35 is 175. So 35x plus 175 equals 75x plus 15. Let me check my math on that. I'm pretty sure. Yeah, 175. So we subtract 35x, we get 175 equals 40x plus 15, and subtract 15, we get 160 equals 40x, divide both sides by 40, and 4 would equal x. Number 18, similar thing. If you extended this part out, you would just get a triangle, which is why you can do this with 3 pairs of parallel lines. X over 40 is going to equal 14 over 32. So x over 14 equals, x over 40 equals 14 over 32. 2 divides into both of these, so I would simplify this to be 7 over 16. So now we have x over 40 equals 7 over 16. Cross multiply, we get 16x equals 280, and I would bet that x equals, it's a decimal, I believe, 280 divided by 16, 17.5. All right. Number 19, same thing. We have 24 over x plus 6 equals 27 over 2x minus 2. We can cross multiply and distribute. We would get 48x minus 48 equals 27x, and 162 plus 162. We subtract 27x, we get 21x minus 48 equals 162. We add 48 to both sides, we get 21x equals conveniently 210. So we divide both sides by 21, x equals 10. And finally, on the back, we have, excuse me. So we have to determine if DE is parallel to AC. So that's going to be true if 6 over 15 equals 10 over 36. So does 6 over 15 equal 10 over 36? Let's find out. So 6 divided by 15 is 0.4. 10 divided by 36, 9.4. So this one was 0.4. This was 0.277. We'll say 8. So these are not equal. So DE is not parallel to AC. For number 21, similar kind of setup, we know segment AD should be 36 because the entire segment is 64. 64 minus 28 is going to give us 36. So we need to check, is 28 over 36 equal to 16.1 over 20.7? 28 divided by 36 is 0.7778. And 16.1 divided by 20.7 is exactly the same thing. So in this case, we would say yes, segment DE is parallel to segment AC. This symbol, the double line, means is parallel to. So the last part, we have parts of similar triangles. What we have in this case is an altitude. So if the triangles are similar, they tell us the triangles are similar, then the ratio of the altitudes is equal to the ratio of the hypotenuses. So that's going to mean x over 24 equals, so x over 24 is going to equal 35 over 42. This fraction simplifies to 7 divides in the both, so we're going to say 5/6. You can multiply, you get 6x equals 5 times 24 is 120, so x equals 20. For number 23, we have a segment bisector of some similar triangles. So what's going to be true is that the ratio of the bisector, so 16 over 11, is going to equal 28.8 over x. We can cross multiply. We get 16x equals 28.8 times 11 is, 316.8. So 316.8. And so x is going to equal 36. We'll just say divided by 16. So x equals 19.8. For number 24, we have a pair of angle bisectors. And so the ratio of the bisectors is going to equal the ratio of the outside sides. So we're going to have 48 over 32. That equals 48 divided by 32 equals 7x minus 10 over 3x plus 5. I would reduce this fraction, simplify this fraction to be 3/2 instead. So now when we multiply, we get 9x plus 15 equals 14x minus 20. Subtract 9x, we get 15 equals 5x minus 20. Add 20, we get 35x equals 5x. And divide both sides by 5, we get 7 equals x. For 25, we have another angle bisector where this side is 16 because the entire segment is 34. So 34 minus 18 equals 16. So what's going to be true is that the ratio of 40 to x is going to equal 16 over 18. So 40 divided by x equals 16 divided by 18. This simplifies to be, let's see, 2 divides into both, so we'll say 8 over 9. So we're going to get 360 equals 8x. And divide both sides by 8, so 360 divided by 8 is 45. So 45 equals x. And for the final problem, we have another angle bisector where this side is 9 and the entire segment is x. So this part of the segment is 9 minus x. So if we add these together, 9 plus 9 minus, I'm sorry, this should be x minus 9, excuse me. So this entire segment is x, so this part is x minus 9. If we add this segment to this segment, we would just get x. So what we know is 22.5 divided by 25 is equal to 9 over x minus 9. If we distribute, we would get 22.5x minus 9 times 22.5, what's that? 198, 202.5. Whew. So minus 202.5 equals 9 times 25 is 225. Let's check that one. Yeah. So we end up with 22.5x equals 427.5. 427.5, and we divide both sides by 22.5, and x equals 19. All right, so that concludes this video over the study guide for the Unit 7 test. Again, this covers similar figures, which we have to find a scale factor, and we use our similarity statement to make our ratios. We covered topic 3, which is proving triangles similar. Remember, the number of sides you're given tells you which similarity statement to use. In the case of 0, it's going to be, you should check for angle, angle. In the case of 2 sides, you should check for side, angle, side. In the case of given 3 side values, you should check side, side, side. For parallel lines and proportional parts, pretty straightforward. If you're given that a segment inside the triangle is parallel to a base, then the ratios of the stacked segments are equal. And lastly, for parts of similar triangles, in the case of altitudes, side bisectors, or a median is what this is actually called. It's a median or an angle bisector. The ratios of those segments to the outside parts of the triangle are going to be equal. I said we get to topic 1. We'll talk about this in class. It won't show up on your test, but it's still good to know how to work these because they come up on standardized tests like the ACT and SAT.